Hello everyone, welcome to my organic chemistry channel. Here I am going to discuss various chemistry topics with you guys. I will also be uploading few practice questions for each topic that we discuss here. So don't forget to like, comment, share and subscribe my channel. Let's get started. So today we are going to study nucleophilic substitution bimolecular reaction, which is also known as SN2 reaction. And we are going to discuss this topic with the help of this reaction as an example, where methyl bromide is reacting with hydroxide ion and giving you methanol as a product. So first, why it is called nucleophilic substitution? And the answer is very simple. The hydroxide ion is acting as a nucleophile and it is substituting bromide. In other words, it is knocking bromide out and forming methanol. And the meaning of bimolecular in this reaction is that rate of reaction depends on concentration of both reactants. In other words, the concentration of methyl bromide and hydroxide ion. So what does this mean? So let's say if you double the concentration of methyl bromide in this reaction, the rate of formation of methanol is going to be doubled. Similarly, if you double the concentration of hydroxide ion, again the rate of reaction for formation of methanol is going to be doubled. So now let's say if you double the concentration of methyl bromide as well as hydroxide in this reaction, the rate of formation of methanol is going to be quadrupled. So that is the reason why this reaction is called nucleophilic substitution bimolecular reaction. In terms of its mechanism, which is also very interesting, and let me show you how. I have shown methyl bromide in its skeletal formula where all the atoms around the carbon atom are arranged tetrahedrally. And this is your hydroxide ion. So I'm going to show you how it attacks on this carbon. So these are the two things which you need to understand. First, why hydroxide ion is attacking on the carbon? So the reason for that is very simple. If you look at this carbon and bromide and compare their electronegativities, you know that bromide is more electronegative atom than carbon, and that is why it is pulling the electrons towards itself. So as a result, the carbon will acquire delta positive charge, and when carbon has got positive charge means it is electron deficient, and that is why hydroxide ion, which is a nucleophile, in other words which is an electron rich species, it is going to attack on the carbon. So once it attacks on the carbon, it leads to formation of this transition state where you can see that a bond between carbon and oxygen has been forming, and at the same time the bond between carbon and bromide is breaking. Another very important aspect of this transition state is that you can see that these three hydrogen atoms, although it is not possible to show it in 3D form, but still these three hydrogen atoms are arranged in such a way that they are in one plane. Alright. On the other hand, if you look at their initial configuration, all the hydrogen atoms were on the left hand side. And now in the final, where the product has been formed, you can see that carbon oxygen bond has been fully formed and bromide has been completely knocked out. So the point I was trying to make here is that in this case your hydrogens are on the left hand side. In the transition state, these three hydrogens are in one plane, and in the product you can see they have shifted towards the right hand side. So the meaning of that is that whatever was the initial configuration of the reactant was, now it has been reversed. This is called inversion of configuration. To understand it a little bit better, I'm going to show you another example where I have replaced these two hydrogens with methyl group and ethyl group. And now, because all these substituents are different, so this carbon has become a chiral carbon, right? And now its configuration is R. So when hydroxide ion attacks on this carbon, again same transition state has been formed, and then in the product you can see that the configuration of the product is S. So inversion of the configuration has taken place, and this is known as Walden inversion. So this is very, very important characteristic of SN2 reaction, which you need to remember. I hope you like this presentation. Thank you so much.